Hi everyone. So in this lecture, I'm going to provide a quick overview of the foundational data modeling. That's something that you definitely have had experience with in your other courses, but I'm going to go over it very quickly because it's going to be an important part of also data warehousing systems. So a data model basically refers to a specification of the data structures and the business rules that we have in our business, and we want to implement them into our databases. So when I say business rules, these could be the relationships, the cardinality, and the modality that we have between the entities, if that's something you remember from the past. But data models are great tools in order to communicate with analysts, with developers, with database administrators about the intent that you have during the design, what kind of data you wanted to collect, what do you want to do with that data. It does include a set of requirement elicitation, which is something I have covered in other courses like system analysis and design. We talk about that in detail, where you go to the business, you conduct interviews and surveys, talk to key and influential people in order to see what kind of requirements you want from the system that will have this database. And also data modeling helps us basically visualize how the entities and attributes are related to each other. So when I say data modeling, it's a structured approach to identify and analyze the data components. Now, data modeling commonly goes through three stages where we create first a conceptual model, and then the conceptual model, which represents the high-level business view, and typically it's an effective way for communicating with the business and understand what business and its processes do and require to have. But then once we have the conceptual view or conceptual model, we move toward a logical model. And logical model is typically, we can think of it as a blueprint of what data is involved. While and what are the things about those, basically what are the attributes of data that we are interested in collecting. So the logical model is basically, it's a next layer down from the conceptual model. And it's one that usually business analysts, system analysts are heavily involved in before designing their applications. But once we have, and it's usually, I think it's shown here, when we do logical data modeling, we typically think of two set of systems. One is a transactional and operational application, which is a set of applications that we're going to do our day-to-day operations with. And next one is the BI and analytical application. So we always try to think of these two. So those commonly end up being handled by common databases, operational databases, whereas a BI applications need a data warehousing or data marts or OLAP cubes, which we'll go through them quickly later. So in the same way, logical data model is also a blueprint for the physical data model. And the physical data model basically refers to an actual implementation. So it gives us a set of guidelines. Imagine you're a developer. Looking at the physical model, you should know exactly what you're developing. So all the tables, all the numbers, all the attributes, all the foreign keys and primary keys, they're all set up. This is again another simple comparison. In the conceptual model, we have entities, name, and relationships. Once we move to the logical model, we need to now think of attributes, primary keys, foreign keys. Same thing with the physical model, and sometimes they might change across these phases. But in the physical model, we'll now think about the table names, the column names, column data types, any other information that we need to do there. And I have a short video which I'm gonna give you the link to look at the details of this if you need to. Now, how do we do this? What's the procedure? As I mentioned, again, the detail of this, it's the focus of another class we have on system design and development. But in brief, first thing first, we gather business requirements. Again, if you go in as a database analyst, as a system analyst, you collect all kind of information to know exactly what the business is looking for. Then you develop a conceptual data model, which includes all the data requirements that you may have for the business. From there, you will create a logical model, which is again the bulk of data modeling work, and it includes taking and discerning all the details between the entities and attributes and the relationships in order to form a conceptual model. And then once we have logical model set, we can use them again as a blueprint that will guide the development of your application, which will also feed the design physical data model. So that's basically what a developer would like to get from you. And once we have that, again, anything you put in the physical data model, even if you don't do it within your company, you should be able to hand that to, let's say, an outsourcing company, and they should be able to develop your database. And then that will lead to deploying applications. Another concept that you might be familiar with is all the details that we put in this physical model. So an entity is basically a thing, anything that's important and it's distinguishable, and it's something that we need to collect information about. Let's say if we're talking about the Blackboard system at Baruch, we're talking about students, professors, maybe courses, course registration. These are entities we need to collect data from. And an instance would be a record of that entity. So each number of you as a student of this class and university could be an instance to the student table. An attribute is basically all the characteristics, all the properties of entities and relationships that we need to collect data from. Anything that matters for you. Let's say we have a student entity, and whatever that's important for the university to collect, let's say your first name, your last name, maybe your social security, the degree you're pursuing, the year you are in the program, your year of graduation, your email address, your home address, anything that's important for the school. And then relationship would be the connection that we have between these entities. And finally, once we have entities and attributes, we also identify a primary key, which is an attribute that can uniquely identify an instance of an entity. It could be also more than one attribute. So whatever that helps us identify a single instance, let's say in the student table. For instance, it could be naturally your social security number. For the same reason, it cannot be your first name or last name, because definitely that's going to be repetitive. This is a simple example. I'm sure you have seen this in your database class. So students enrolling in courses, so the relationship is enrolling. And this is just one way to represent it. There are multiple other ways and they're all fine. So we have a student entity, courses entity, and each of them have a set of attributes. So a rectangle is an entity. In this format, a circle would be an attribute, and the diamond represents the relationship. And the relationship can have its own attribute, or we can add an intermediary entity, and then that that entity can have a grade. There are different ways to do it. I'm sure you have reviewed this in your other classes. So what kind of relationships might exist? We might have, let's say we're talking about customers and orders and products. We can have one-to-many. A customer can have many orders. We can have one-to-one. An order is only mapping to one customer for sure. We can have an order that there's more than one customers in it. And then the other relationship we have, it would be many-to-many, which is many products can be bought by many customers, and also many customers can order many products. And usually, when we talk about relational databases and SQL databases, many-to-many relationships need to be broken down into another form, which again we'll talk about that as we go through this data modeling in this course. But if I want to just help you refresh your memory, a binary one-to-many relationship is when a customer have many orders, and basically one instance of a customer can be associated with many instance of the order. We can also have, again, customers and products when you have many-to-many relationship, and then we have an intermediary table, which is an order, and then one product can be part of many orders. An order can have multiple products, so many-to-many. We can have one-to-one relationship, which is when one instance of an entity is related to one, and at least one instance, minimum and maximum one instance of another entity. Example would be a parking space can be assigned only to one employee, or one employee can be assigned only to one parking, or maybe zero parking. So it could be 0 and 1. And you probably have heard of the Unary relationship. And the Unary relationship is when an entity has a relationship with itself, meaning that one instance of an entity can be related to another instance of the same entity. Let's say this is a city database, and we want to know people who got married, and if that's our database, a person, an individual, can be married to another person from the same table. So it has one and only one, or 0 to 1, it could be married or not, to the same table. So let's say we have a table, one attribute would be the person is married or not. It could be yes, no, and then who is it married to if that attribute is yes. And then it would be the name of the second person, or the name of the spouse. And then we have also Unary one-to-many relationship. Let's say students have, or employees in an organization have advisors. So one employee is basically reporting to another employee. And this relationship is one-to-many because we could have one employee, we could have many employees that are reporting to a manager, which is also an employee. So that relationship would be one manager is related to many employees, and the relationship is to supervise. So that's one-to-many relationship. And at the same time, we can have many-to-many relationship between the same entity. So imagine we have a database of parts. A part might also include a product, and a product is has multiple parts, and one part can be part of multiple products. It might sound a little confusing, but basically you can draw two entities, just do part here and have many-to-many relationship. That's how we show it, a Unary relationship. So basically, an entity, multiple instances of an entity have relationship with multiple instances of the same entity. Alright, so I want you now to take a quick break. So pause the video here, and I want you to draw a quick diagram of, imagine an online book selling system, let's say Barnes Nobles or anything else that you can think of. Identify the entities and attributes and the cardinality in that. So what I'm gonna do is that I'm gonna open a little assignment. You can draw this in a PowerPoint or Visio, or there's online free software that you can use like draw.io. So use any of these tools to identify the set of entities and attributes and relationship between them for an online book selling system.